Non-uniqueness of Lagrangian. Consider Lagrangian for one degree of freedom, coordinate x, velocity x dot, and time t. We know that Lagrangian need not be unique as long as it generates proper equation of motion. In other words, if we add to Lagrangian some additional function, but it still generates the same equation of motion, then this Lagrangian is just as valid as the old one. Let's consider new Lagrangian L prime, which is defined in terms of old Lagrangian plus some new function f. As long as partial derivative of f with respect to x is equal to full derivative with respect to time of partial derivative of f with respect to velocity x dot, the new Lagrangian L prime is equivalent to L, because it will produce exactly the same equation of motion. One example of such function f is full time derivative of arbitrary function g of x and t. If f can be written in this form, then new Lagrangian L prime will be equivalent to the old Lagrangian L. Let's prove it. We will substitute this expression of f into the Lagrange equation. When we do so, we get on the left-hand side partial derivative with respect to x of dg dt, and on the right-hand side we'll have full time derivative of partial derivative with respect to velocity of full derivative of g with respect to time. So our goal is to determine whether these two left-hand side and right-hand side are equal. Let's use chain rule to find full derivative of g with respect to time. Then we'll have, for the first term, partial derivative of g with respect to x times x dot. And for the second term, we'll have partial derivative of g with respect to time. Now we will substitute this into the partial derivative with respect to d dx dot. And we will find that partial derivative with respect to x dot of dg dt, full derivative, is simply equal to partial derivative of g with respect to x. Just the first term here survives. Thus, our expression here is rewritten as partial derivative of dg dt with respect to x on the left-hand side, and on the right-hand side we have full time derivative of partial derivative of dg with respect to x. Now you can recognize that these two differentiation operators can be exchanged, and so in fact we have the same expression on the left-hand side and on the right-hand side. Thus, we can always add to Lagrangian another function f, which is itself a full time derivative of an arbitrary function of only coordinate and time, and still get the same Lagrangian. Let's look at a very simple example. Let g be x squared over 2, so that f becomes full time derivative of g, or simply x times x dot. If we add this function to the Lagrangian, we will still get the same result.